All right, good morning. Great to see everybody. Hey, Elena. What's up, Matthew? Caitlin, how's it going? Okay. So, let's go ahead and talk about the rest of our conic sections today. All right, which is parabolas and hyperbolas. But first, just a quick warm-up here to remind us what we talked about. So yesterday was mostly just taking general form and putting it into standard form. So first step being, take this, move it over to the right side, and then on the left side, group the x's and group the y's together. Since there's these coefficients in front, then I need to factor each of those out. So 2x squared minus 2x. I'll leave myself some space. Oops. Uh-oh. Okay, I fixed it. Plus, I'm going to factor out that 3 y squared plus 4y, leave some space, equals 10. So now we need to complete the square for both of our binomials here, turn into a trinomial. Negative 2 over 2 is negative 1. Negative 1 squared is 1. When we add that to the right side, we're not just adding 1, we're adding the 2 times the 1. Don't forget about that. And then here, 4 divided by 2 is 2. 2 squared is 4. So plus 4, but we're not just adding 4. We're adding the 3 times the 4. All right, so a couple key differences for the ellipse. But now let's simplify the left side. So 2 x minus 1 squared plus 3 y plus 2 squared equals 10 plus 2 is 12 plus 12 again, 24. Now I want this 24 on the right side to be a 1, so I'll divide by 24, and I'll do the same thing everywhere else. Divide 24. Divide 24. That turns the right side into 1. And then just simplify each of these fractions. So 3 over 24 simplifies into 1 over 8. 2 over 24 simplifies into 1 over 12. Great box. So here's our ellipse. And again, once we have this stuff in standard form, we could find center, we could find foci, we can find vertices, covertices, we could graph it. We can do so much, so many fun things. Okay, so let's talk more about our other ones then. All right, so we've done ellipse and circle. So our next option is parabola. So if we slice through the cone at an angle, then we get this parabolic shape. And then lastly, we have a hyperbola. So if we cut at an angle steep enough that it cuts through both the top and bottom cone, then it ends up as a hyperbola. Gonna go back for a second, for sure. Cool. And so the hyperbola, notice for these pieces of the hyperbola, okay, these look like parabolas. It looks like a parabola facing up and a parabola facing down. It's not technically a parabola though. It's slightly, parabolas have certain other properties that we'll talk about that these do not. They look similar, but parabolas and hyperbolas, those shapes are actually distinctly different. So let's first talk about parabola. A parabola, by definition, we're used to thinking about parabolas that, we know they have this kind of U shape and the vertex. But now we're going to introduce some new stuff. One being a focus. So a parabola actually has a focus, like ellipse has two, right, foci. A parabola has a focus. It also has a directrix, right, this red line down here. So parabola is defined as a set of points that are equidistant from a focus and a directrix. So what that means is if we pick any point, so like we say, if I pick this point here, it is the same distance from the focus to this line, the directrix. All right, and that would be the case for any point that I choose. The distance from here to here would also be the same distance, okay, whatever that distance is. And I have a neat little interactive here that shows that. Okay, so let me make this a little bit bigger. Oh, that's hyperbola. Okay, so for parabola, so as I can see, if I pick any point, the distance to the focus, 4.23, distance to the focus, 4.23. And as I move to any point on that parabola, those distances are changing, but the two distances are always exactly the same. All right, which is pretty neat, I think. I think it's really neat. All right, so no matter where you are, the distance from the parabola to the directrix or the parabola to the focus are the exact same length. So pretty cool. And same thing, if I move the directrix up and down, it changes, but the property is still the same. And always the same distance between. Okay, let's go back. The equations of parabolas look like this. All right, we're used to quadratics looking in one of these two ways. All right, let me move that over. All right, that's what we're used to seeing, like from Algebra 1 or Algebra 2. And so now we have these different equations of parabolas. Now that we know that this thing called the focus and the directrix exist, then here's a different way that we can write those equations that help us determine those. Okay. Right. This first one, this would give us a parabola that's either facing up or down. Oh, no, not up or up. Okay, but so that's if the x variable is being squared. However, if the y variable is being squared, then this will give us a parabola that opens up to the left or to the right. So again, this is an example of one of those little details that we have to remember that are easy to screw us up, right? Okay, which one is it that is up or down or left and right, etc. Right. And like we're used to for both of these, the vertex is HK. Right, so either it's H and K or H and K. All right, now we also have this variable P. Now what is that? Okay, that's something that's definitely hasn't showed up in one of our previous equations, right? There's no variable in there. It's just A, B, X, C. Okay, so this lowercase p is this. So what is the definition? It's the distance from the focus to the vertex. So between the focus and the vertex, that is whatever that number is. Also, that's the same distance between the vertex and the directrix. Or if we start at the focus, if we go 2p to the right and 2p to the left, that also gives you those 2 points. Okay, but the main point is these arrows that I've written here. That number p, whatever it is, the distance between the vertex and the focus, and it's the distance between the vertex and the directrix. Directrix is a fun word to say. It's good. Try it. Say it out loud. Directrix. It sounds cool. It's just something about the X, you know. All right, put the equation of the parabola into standard form. So this form that we're looking at, I see that this has an x squared in it, but there's no y squared. So when I go back to my original two equations, I can tell then that the equation I'm aiming for is this one, because this has an x squared. But this first equation has no y squared. There's just a y, but then there is an x and an x squared. So I'm aiming for the setup of this first one. The first thing I'm going to do is I'm going to take this stuff and move it over. Leave myself some space. So minus 16y plus 135. Now, I left myself some space because, you guessed it, we're going to complete the square. All right, so I'm going to look at 6. 6 over 2 is 3. 3 squared is 9. Have to do the same thing on the other side. So add 9. There's no coefficient to multiply it by. I didn't have to factor out anything from the coefficient of x. So plus 9 on both sides. So this left side factors into x plus 3 squared. The right side, negative 16y plus 135 plus 9, 144. Okay, so far I'm almost to what I want it to be. I have my something squared on the right, but on the left I have x minus h squared. On the right I want it to be some number times y minus k. Let me get rid of this. So I'm going to factor out this negative 16. 144 divided by negative 16, that would be minus 9. And let's do one more thing. Whatever this number is, we know is 4 times p, right, as we see in our equation, right? 4 times p. That's whatever number is in front of the y minus k. So let's just do some quick thinking. 4 times what number gives me negative 16? Well, 4 times negative 4. All right, so I'll go ahead and break that down. All right, so if I wanted to graph this, I know what that p is negative 4. Okay, we're not going to focus on graphing. Like I said last time, if you're wanting to do that conic sections AFA, check out the math analysis playlist on YouTube. Parabolas, Parabolas 2, Hyperbolas, Hyperbolas 2. It gets more into depth. So very similar style to what we've done before, though. Move things to the other side, complete the square, rearrange some stuff as we need, and get the final answer perfectly. Score 100 touchdowns. That's right, 100. Okay, hyperbolas. A set of points whose distances to two fixed points, foci, so we're back, we have foci again. The distances to the foci have a common difference. Now, what does that mean? Good question. Let me show you. So let me go back to my little interactive here. But I have one for a hyperbola. Okay, so I have this hyperbola here. And as we can see, oops. So if we look up here, PA, so that's the distance from this point to A, the focus. PB, the distance from this point to this focus, right? There's two foci. And then here it tells us the difference. So if I subtract them, right now I get 2 if I subtract those distances. Well, as I move this hyperbola, or as I move this point, those distances change, but look, PB minus PA stays 2. Right? No matter what these distances are, if I subtract them, I always get 2. Right, so that's what that definition of hyperbola refers to. And so we can change how these hyperbolas look. They can be really flat. So same deal. Difference is always 0.9. Right, or we can make them more narrow. But same thing, as I follow the points, the distance between, or the difference is always 3.5 no matter where I move it. So that's what we're talking about when we reference this definition. Here's the equations of the parabolas. Okay, these should look pretty familiar. Okay, these parabolas, so whenever it's, well, I guess, hold on, sorry, what I was saying before. These should look pretty familiar. This is almost exactly the equation of an ellipse except these have minus signs instead of plus signs. All right, for an ellipse, it's a plus sign in between them. For hyperbolas, we have subtraction between the two terms. All right, so that's what changes it into a parabola. This first equation would give me a parabola that is opening left and right, east-west or something called. And this second equation, so if the y value is first, then that is a hyperbola that opens up and down. But if the x is the first term, then it goes left and right. Put the equation of the hyperbola into standard form. All right, so standard form, same process we've been doing, you guys. So first off, constant, move it to the right. On the left side, group stuff together. So let's group the x's. Let's group the y's. Equals minus 116. I have these coefficients in front of the squared terms. So just like with ellipses, I need to first factor those out before I complete the square. So 36 x squared plus 2x. Oh, let me leave myself some space so I can complete the square. Minus 4 y squared minus 8y equals negative 116. Complete the square twice, so 2 divided by 2 is 1. 1 squared is 1. But I'm not just adding 1, I'm adding 36 times 1. Negative 8 over 2 is negative 4. Negative 4 squared is 16. But I'm not just adding 16, I'm adding 4 times 16. Now I can factor. So left side 36 times x plus 1 squared minus 4 times y minus 4 squared equals, let me calculate, negative 116 plus 36 times 1 plus 16 times 4. Oh, wait. I messed up. Right, it's negative 4. And I almost forgot that. So negative 4 times 16 on the right. Right, very important. So all that on the right side equals negative 144. Okay, just like before, we want the right side to be 1. So let's divide by negative 144. But we got to do it everywhere. Right side's 1. Now we just have to simplify the fractions. So 4 over 144 would simplify into 1 over 36. Oh, it's just the same. Cool. Notice that the negatives here would cancel, so that's why I put a plus sign. Oops. 36 over negative 144. So that would simplify into 1 over negative 4. So I'm going to put the negative sign out here. Losing my voice. Huh. And then one quick last step is notice from my equations that the minus sign is always in the middle. So I'm just going to quickly rearrange this so that the minus sign is in the middle. So I'm going to put y minus 4 squared over 36 first, and then minus x plus 1 squared over 4 equals 1. And there's my answer. This is the hyperbola. Questions? Okay. I sent you some practice stuff. It's just like a little bit of mostly practicing, it's like a little bit of graphing like a circle or graphing an ellipse, putting things into standard form from general form, so just kind of like the process of move the constant, complete the square, rearrange, simplify, stuff like that. All right. Right? Also, something that I've been telling all my classes, I would really love to, this is not, homework assignment. I would really love to kind of hear more from you guys. So I know we kind of talk, every now and then you guys will say something, or a group of you will talk in the chat during class, or at the beginning at least. But I would love it if you guys would like send me an email just with like an update on yourself, on just life in general. How are things going? How's school going? It doesn't have to be focused on school, but how's school going? How's family? How's being at home? Are you going crazy? Just kind of stuff like that. I would genuinely really like that, because I miss not being able to talk to you guys or all my students just in normal class. So we can have a base form of interaction through the Twitch chat, but I would genuinely like to hear from anyone and everyone. So whether you're someone that does talk during class or just sits there and never types a word, I would, not required, but I'd like to hear from you, no matter who you are, because I miss you guys, and I want to make sure you guys are doing okay, and just kind of hear about everyone's lives and what's going on.